Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we from the SC1 will present to you about the historical development of Rubu Mujayyab. My name is Nur Hidayah Binti Omar. My matric number 1181352. Next. Okay, this is about what will we discuss in this presentation. There are 8 components. Next. First, the concept of Rubu Mujayyab. Next. Rubu Mujayyab is literally means a quarter. Rubu Mujayyab is a calculating tool in the form of a quarter circle. There are also those who say that Rubu Mujayyab is a revolution of the quadrant, which is a calculating tool that was once raised by Al-Khwarizmi and Ibn Shatir. Hendro Setianto interpreting Rubu Mujayyab or sign quadrant is an astronomical calculation tool to solve the problem of spherical triangles in astronomy. In the Encyclopedia of Hisab Ru'yah, Rubu Mujayyab is a tool in the form of quarter circle which is used to calculate geometric functions which are very useful for projecting the circulations of celestial bodies in a vertical circle. In its use, Rubu Mujayyab can be installed vertically or horizontally depending on its needs. The vertical position is when the Rubu Mujayyab is installed parallel to the stative rod. The vertical position is usually used to measure the height of objects, including the height of stars, moon, sun, buildings, mountains. While the horizontal position is when the Rubu Mujayyab it is installed perpendicular to the pole. This horizontal position can be used to determine the north-south direction of the earth and the direction of the Qibla. Next, we go to Qibla.
Bismillahirrahmanirrahim. My name is Nur Aqila binti Ahmad, matric number 1181358. Next, the history of Rubu Mujayyab. The ability to know the time of day and positions of geography accurately actually has started since ancient times. Rapid developments are also taking place in the world of astronomy. Early astronomy flourished on practical needs of primitive civilizations around 3500 century before Christ. In everyday life at that time, their job heavily reliant sunlight. They will work throughout sunrise and return during sunset. Finally, they realize a size from their shadow change from time to time. Therefore, they determine time of day by looking shadow that seems on some objects like trees, stones, and so on. Next. Before development of Rubu Mujayyab, there are other tools that was developed. First, a gnomon. In 20th century before Christ, most humans from varied teams had used gnomons as timers, even though they used solely the length of the shadow and did not reach the direction of the shadow. A gnomon is a stick used to determine time based on the sun. Second is sundials. Sundials is used to determine the pacing of time which is connected by sun appearance. Next was Rubu Mujayyab was substitute Rubu Mujayyab was substitute from the astrolabe. Both are type of ancient astronomical computer which were used to solve problems relating to time and the positions of solar system. Astrolabe was introduced by Hipparchus in 150 before Christ. It was started and introduced to the Islamic world on the 7th and 8th centuries. Ancient equipment used to measure celestial objects in the celestial sphere. A spherical astronomical tool used to determine the location and predict the positions of the sun, moon, planets, and stars. Next, Rubu Mujayyab. Rubu Mujayyab was known after the astrolabe. Simpler than astrolabe and a tool for observing things in the sky had been practiced since around the 2nd century AD by Ptolemy. The Ptolemaic quadrant made from wood or stone boards is in the form of quarter circle divided by 90 degrees. Next parts of Rubu Mujayyab. Next. Rubu Mujayyab has many parts and each of these parts has its own function. First, markas. Markas is a small hole punctured by a rock or thread. Second, cause irtifa, a curve on Rubu with an angle of 90 degrees and having 12 constellations. Third is Sitini. Sitini is a line on one side of the Rubu that starts from the markas to the end of the cause and has an incision divided by 60 degrees. Fourth, Jab At-Tamam. Jab At-Tamam is a line on one side of the Rubu that starts from the marcus to the beginning of the cause and has an incision divided by 60 degrees. Next, juyuk mabsutah. Juyuk mabsutah is the lines that descend from sitini to cause. The sixth, juyuk makrusah is the lines that descend from jab at-tamam to cause. 7. Dairah al-mil, the curve of a quarter of a circle existing 24 degrees from sitini and jab al-tamam. 8. Qa'imah al-zil al-mabsut, the line descending from sitini to cause. If 7 degrees is called qa'imah al-aqdam and if 12 degrees is called qa'imah al-asabi'. Next. 9. Qa'imah al-zil al-mankus, the line that descends from jab al-tamam to qaus. If 7 degrees is called qa'imah al-aqdam and if 12 degrees is called qa'imah al-asabi'. 10. Qaus al-asri, two curved lines starting from the beginning of qaus until sitini. One of them is called qaus al-asri al-awwal at 42 degree and 20 inch sitini, and the other is called qaus al-asri al-thani at 26 degrees and 30 inches sitini. 11. Dairah at-tajib, two lines of a semicircle curve that begin at the marcus and end at the qaus. The first line is called at-tajib al-awwal, which ends at the end of the qaus. The second line is called at-tajib al-thani, which ends at the beginning of the qaus. 12. Haddafatani, two branches of a part on one side of the rubu that protrude from the rubu, which is common in the sitini part. 13. Khat al-imtihan, the line that exists from the beginning of the qaus through the meeting point of dairah at-tajib and the ends at the end of the qaus. Next. Next, the equipment on Rubu Mujayyab. First, khat is the thread that is pricked at the marcus. Second, murid, an indicator thread that is tied or twisted on a khat of either 2 or 3 indicator threads. And third, shakul, a stone or weight tied at the end of the khat. Next, we go to the next presenter.
Okay, next, the types of Rubu Mujayyab in Islamic astronomy. The next, first, the sign quadrant. The tools using for solving trigonometric problems. In physical, it has sharp plate, which contains grid lines of the scale of trigonometric functions, by which readings and one of way to solve trigonometric equations. This equipment can also be set up to measure the altitude of object on the sky, measure the celestial angle, telling time, determining the time of prayer and qibla for Muslim. Next. The universal. The main functions are to solving latitude problems in any places. These quadrants had either one or two sets of Shakzaya grids and were developed in the 14th century in Syria. Jamaluddin al-Maridini defined an analog computer for solving problems of spherical astronomy. Next. The third one is the horary quadrant. This famous instrument was opposed as graphical equipment for finding the time of day in terms of the solar longitude and the instantaneous altitude. Horary quadrants calculate the time from the altitude of the sun. The major functions are to finding the direction of qibla, because important direction that should be faced when Muslims pray. Also, it be able to determine prayer times by guidance locations of the sun or stars. Next. Fourth, the astrolabe quadrant. This is a quadrant advanced from the astrolabe, the astronomical instrument which is compatibility for usage in any location on Earth. The lines that carved on the front indicates the position of the sun across the sky. According to Ali ibn Khalaf al-Shakka's astrolabe quadrant, able to solve problems of spherical astronomy for any geographic latitude, though in a somewhat more complicated fashion than the standard astrolabe. Next, the last one is the mural quadrant. Mural quadrants, known as one of the largest astronomical instruments, which were measuring device constructed on or complicated into a wall. Its permanent setup to a meridian wall and usually used to measure meridian altitudes. In addition, it was performed to measure the altitude of stars above the horizon at their transportation at the celestial meridian. These devices have the strength to measure angles from 0 to 90 degrees. Okay, next. the famous inventors of Rubu Mujayyab in Islamic world. Next. First, Ibn Shatir. Alauddin Abu Al-Hasan Ali bin Ibrahim Ibn Shatir was a Syrian born in 1304 and he dies in 1375. The age is 73rd year. He mastered in mathematics and engineering automatically. He wrote on the ordinary planisphere astrolabe called Al-Ala al-Jami'ah, the universal instrument. This design were innovations and modifications of the simpler, more useful sign quadrant, which is one astrolabe and one universal instrument. Then Ibn Shatir continued to make astronomical tools at an advanced age for the creation of Rubu Mujayyab. Rubu Mujayyab that generated by Shatir expanded and is still used by universal society, especially in Sumatra. Next. Al-Khwarizmi. Abu Abdullah Muhammad ibn Musa al-Khwarizmi was born in Persia of that time around 780 and died after 850. He was a mathematician, astronomer, geographer, scientist, and astrologer, often called the father of algebra because he was the first founder algebra method to the world. In mathematics, one of the most important knowledges of Al-Khwarizmi is in the creation of the number zero and Hindu-Arabic numerals. He successfully published book Al-Kitab Al-Jabr wa Al-Muqabalah, the compendious book on calculation by the restoration and the opposition, which most popular in that time. The book was a compilation of extension of known rules or solving quadratic equations and for some other problems. Other than writing book, he also involved in produce the astronomy instruments. Next. Next, Al-Biruni. His real name was probably Abu Raya Muhammad ibn Ahmad Biruni, was born in the city of Qat, Khwarizmi in 5 September 973 and died 13 December 1048 in Ghazni, today's Afghanistan. Al-Biruni is greatest scholars in and century to 4 Hijri, who expert in physics, astronomy, mathematics, language, and history, famous with title Father of Geodesy because his contribution in earth sciences and geography. Al-Biruni himself makes observation on the sky that most first developed in Khwarizm. He also been known that had made some observatory astronomy in several districts in Khorasan and reported have used quadrant during 3 meters. Okay, next.
Next, the new instruments replacement of Rubu Mujayyab. Okay. First one, Global Positioning System, GPS. The GPS is a radio navigation and positioning system which uses satellites. The full name of the GPS is the Navigational Satellite Timing and Managing Global Positioning System, which is Navstar GPS, but people are more familiar with GPS. This system can be used by many people at once in all weather conditions, and it is designed to provide precise three-dimensional position and speed, as well as continuous time information throughout the world. It is a system of direction guidance or navigation which utilizes the help of signals from several satellites orbiting the Earth. With certain orbital positions of the satellites that serve the GPS can be received throughout the Earth's surface to provide position, altitude, and time information with a high accuracy. In addition, it can also be used to determine the altitude, compass, position from a sun and a moon, the map, the navigator, and its section. Next, theodolites. A theodolite is a precision instrument used for measuring angles both horizontally and vertically. Theodolites can rotate along their horizontal axis as well as their vertical axis. Theodolites have an internal optical device that makes reading circles much more accurate than other instruments. Also, because of theodolite allows you to take fewer repeat readings, these measurements can be made much more quickly. Theodolites with optical instruments have advantages over other layout tools. They have more precise measurements. They are unaffected by wind or other weather factors, and they can be used on both flat ground and sloped ground. Theodolites have many advantages when compared to other leveling instruments such as greater accuracy, internal magnifying optical system, electronic reading. Horizontal circles can be instantly zeroed or set to any other value. Horizontal circle readings can be taken either to the left or right of zero, and repeat readings are unnecessary. Okay, next, compass. In ancient times, people could identify the direction by observing any position of the sun when it rose in the east and set in the west. At that time, they also marked the point of sunlight against the earth from the morning to sunset. Subsequently, human knowledge developed by observing the constellations that can be used to show a direction to the north, such as any constellations of Polaris. By getting north-south, they can found another direction. After that, they will mark a direction. However, this knowledge was sometimes considered impractical because it depended on the weather conditions. If the weather was cloudy and dark, then humans could not know the direction pattern. Moreover, it can be founded any tool like practical direction such compass. Okay, next, functions of Rubu Mujayyab in Islamic astronomy. Okay, functionally, the Rubu Mujayyab has several main functions, such as first one to calculate tools. As a calculation tool, this Rubu Mujayyab can be released from the stative and placed horizontally. Mathematically, the main function of the Rubu Mujayyab is a calculation tool, which is known as an orthogonal grid. Second, to measure instruments. As a measuring tool, the Rubu Mujayyab collects physical data or observational data that can be processed by using certain equations which suit the needs of any user. And the last one is an astronomy table. In Rubu Mujayyab, there are several lines which show astronomical data, such as the position of a sign in ecliptic longitude and the declination of a sign. For example, the calculation of Rubu Mujayyab in the trigonometry sign. Sin was defined as the ratio of any side on a triangle in front of an angle to the oblique side, provided that the triangle is a right triangle or one of the triangles on 90 degrees. To identify the value of sin in Rubu Mujayyab from an angle, it can be read directly on the LCT side. There are several calculation steps of the value of sin 35 with Rubu Mujayyab, such as first one, put height on cos 35 degrees. Second, draw a straight line from cos al-irtifa to al-sitini. Third, any position of height from the beginning of the markas to al-sitini is worth 34.35 degrees. Because the concept of Rubu Mujayyab is sexagesimal, the value was divided by 60. Subsequently, the result of 34.35 divided by 60 is 0.5725. Moreover, the value of sin 35 degree is 0.5725. It has been compared against calculations using a calculator, with the value of sin 35 degree being 0.5735764. Okay. Next, we move to the next presenter.
Okay, the next one is measuring a celestial altitude with the quadrant. Next. Some authors state that two people are required to use it successfully. One to take the side and one to read the chord, which is plumb line. At the point, one views the face of the instrument to read the angular position of the chord relative to the radii segment of the instrument. However, it does help to have another person write down the scale readings as they are taken if a single operator is not able to do such because of environmental conditions. The single operator not having the capability to sufficiently hold the device stable, retaining the optical alignment with just one hand. This is the reason why the old wooden sculpture exhibits an assistant standing next to the observer, not to read the scale but to record the results. Okay, next to Akila.
In a conclusion, next. Rubu Mujayyab provides many advantages and convenience in using it. Rubu Mujayyab is an instrument in the shape of a quarter circle. This equipment is useful for solving problems in the field of astronomy related to the implementation of worship, such as the beginning of the Hijri month, prayer times, and the positions of the direction of Qibla, and others by using the concept of a spherical triangle. The current generation needs to be aware of traditional equipment like Rubu Mujayyab because without traditional equipment, there will be no modern equipment. That's all from us. Thank you.